I want to tell you a quick story about my first day on the job as a professional entry-level front-end software developer. So I came out of a background with no development experience. Professionally, I was one of those people that did automations in my bedroom in high school, and I did it when I worked in other companies, and I landed a job in software development by a miracle. And the first day I get into the office, everyone's super nice. It's a great team. It was an amazing organization. And my new boss is taking me around, and he brings me to the most senior developer on the team, in fact, in the entire organization. And he says, "Hey, I want to introduce you to our new hire, Sam. And then he pauses, and you can just see him trying to think, what is he going to say? Because I don't have a degree in computer science at the time. I didn't have any professional experience. And he says, he's a hobbyist. And both of these guys are good friends now. The other guy, he doesn't know what to say either. And he goes, a hobbyist, eh? And I remember thinking, I have absolutely no way to prove that I can do this job other than by doing it. And that's what today's video is about, is that when you start taking on automations in an organization and you don't have the background and the chops and all that stuff, there's a specific set of rules that you need to follow. There's some check boxes that you need to check off. And if you can check these off successfully, you will win the trust of the senior developers in your organization, if they're reasonable people. Most of them are. But they can be a little crusty and hard to warm up at first. So today's video is about how to do that. So this is part one of a two-part series. Now, before we jump into this, if you have a moment, if you like this video and you get through it, if you could like it, if you could subscribe to the channel, that would help me a ton in continuing to make content like this. So thank you so much, and let's jump into today's topic. So I want to take you on a simple thought experiment. The question is, how much computer architecture has changed with the advent of all this new AI technology we're seeing with LLMs and image processing and all of that? And the answer is quite simple. Absolutely nothing. Okay, so let's look at that. The basic computer architecture is still, and this was invented in 1945, so right at the dawn of actual digital computers. The CPU or the GPU, sometimes you have two of these, but they're both processing units. That's what the P and the U stand for. This is where the calculations in the computer are happening. This is the most expensive part of the machine. It's the fastest. The RAM is where you're storing your programs, and it's where you're storing all the data that's getting ready for those calculations. And then the storage, the hard drive, that is where we keep the results of our programs long term. Okay. Now we know that RAM's always been pretty fast comparatively. Storage has gotten much faster in the last few years with things like NVMe's and just the whole solid state revolution. But programming languages themselves are still very much based on this concept of storing things in RAM is really easy. Storing things in storage is hard. So let's say that you're doing some kind of data processing on some customer data or something, and you've got like a spreadsheet sort of CSV thing. The RAM is where you're going to store all that customer data temporarily, or as much as you can fit. You're going to push it into that CPU to do your calculation. Maybe you're trying to analyze something about this, or you're trying to maybe you're going to want to call an LLM and so you want to do something with that push there. You're going to then take the results of whatever data processing you did. You're going to bring it back into the RAM. That's where the variable gets stored out of that. And then the RAM, once you're completely done with running your program, that RAM is then you're going to take the results and store it into another file like a CSV, and then push that file into the file storage. So the file storage ultimately doesn't have a lot to do with what's happening during the running of the program. Unless you're accessing a database, we won't get into all that. And like we talked about just now, hitting an LLM would be leaving the computer, right? So that would be a networking call. But this is the basic architecture. A parallel to this, if it helps you think about it, is think about Christmas Carol with Ebenezer Scrooge. So he's got his clerk sitting in the bank. That clerk in the bank is taking a stack of papers, maybe bills or invoices, things that he's paying money out and he's getting money back, and he's doing calculations on those temporary papers. Once he's finished his calculations, he then takes the results of those calculations and stores them into a file cabinet. And that's ultimately, before computers, humans were using this exact same process to do financial transactions and other kinds of record keeping. So doing it digitally is not necessarily new, but if you can grasp this concept, it will help you a lot in writing solid programs and knowing how to navigate the code that you're getting back, say, from ChatGPT. Now let's dive into how programmers think. So here's the most basic way that programmers think. Inputs and outputs. That's it. If you can understand inputs and outputs, if everything else I say doesn't make sense to you, this alone will allow you to make remarkable headway in AI implementations. What do we mean by inputs and outputs? Inputs are pieces of data that come into whatever you're doing in the system. Now, what you do in the system is your program. So this is the thing, you're going to go to ChatGPT or some other LLM code assistant, and you're going to say, write me a script that parses a CSV file of my customer data, and I want to summarize a customer reach out email, something like that. That program that comes back from the LLM, let's say it's, that program, let's represent it by a bunch of little Christmas elves inside of a box. They're going to take that input and they're going to transform that input. So if it's a bunch of customer data, that's going to turn into an email, a plain text email at the end. And so these elves, the code is working inside of this box to transform it. And then it pushes it out at the end. Now, I bet you, if you can remember from the previous section here, you can guess where this is happening. Okay, this is the actual processing part is happening on the CPU, but all of the code all the stuff that's coming in as an input here, that is saved in the RAM, and then it gets outputted back to the RAM, and then eventually to storage. So that is inputs and outputs. Fundamental concept. You have to understand this. The input looks like this, as the example we just gave. So let's say you've got two customers here, Emily Hall and Sabrina Clark, and we've got some information about them. So we take all these inputs, and if you look on the right side here, now we've still got this, we have this output that's coming out, and the output now includes an email to the customer. You notice that email is a totally different format. It's a totally different form. It's generated by AI, but it's based on the input that went into it. If you can understand this, you'll be able to pull together a lot of automations. It's the starting place of pretty much all programming. When you think about, I want to create an automation, if you're not sure where to start with the inputs and then figure out what outputs. So what data do I have available and what do I want the final result to be? I can ignore what I'm going to do in between for a little bit, but if I know what data I have access to and what data I want to output, then I'm going to be golden, and I'm going to be able to describe pretty well to ChatGPT what kind of code that I want. The next programmer knowledge that you need to think about is what's slow and what's fast. Actually, there are two main things that you can mess up and make your programs run really slow. Most everything else is fast. So let's look at these. The first one is what I'm going to represent with this red dragon. And the second one I'm going to represent with this blue dragon. We could go into tons of detail about how these works and how to slay these dragons and where the chinks in the armor are. But we're not going to do that because mainly I want you to recognize the dragon and the color of the dragon. So if you're working with some code you've produced to a ChatGPT, or better yet, you haven't even asked ChatGPT to produce it, and you're recognizing, oh, this could be one of those dragons, and they come up all the time, then that's where you go, okay, I'm really going to pay attention, make sure I don't make a mistake here. Okay, the red dragon is called loops, so that's when you do something over and over and over again. And the blue dragon is called network requests. And that's when you stop what you're doing and then you go out and you ask another computer somewhere on the internet. It happens all the time. Pretty much anytime you want to make an AI request, you're doing this. You're making a network request. So these dragons are in your code all the time. If you handle them right, you're fine. But if you mess them up, okay, we can have a problem. So let's start with loops. Loops, they look like this. For every customer, do something. Okay, that's totally normal, totally acceptable, totally fine. But then it starts to get not so good. For every customer, after I do something, before I go to the next customer, stay on this customer. Now, for every customer sale, can you see how that could become a problem? What if this customer has bought 500,000 items from us? What if this customer is a business? Let's say that I have, 5,000 customers, but for every single one of those customers, I got to go look up every single customer sale for each of those. That could take a long time. Oh, and imagine if there was a network request happening in between. That could be even worse. Now, this is bad, but it's considered often acceptable depending on, what you're doing. This is sometimes common. When you get really bad is when you go down to the third one. And I'd have to go into a lot of math to explain how bad this is, but trust me that it's not just 1 + 1 + 1 = 3. It's way worse. So if you say, okay, for every sale, now we want to go look up all the salespeople and see if they made that sale. Okay, that's the type of thing. There's way better ways to do this. But sometimes you find yourself wanting to do this and just don't ever do it. So the first one, totally okay. Second one is like, oh, okay, be careful. This could be bad. And the third one is just absolutely unacceptable. This will ruin your program. Okay, so that's loops and the things to watch out for there. So the blue dragon is network requests. So as we said before, this is when you're stopping what you're doing. You've moved data from your RAM into your CPU, and then you go, okay, hey, I've got to go ask another computer about something. So go back to that input and output thing we were talking about, and you've got your little Santa's elves, and they're working inside your program, and they're doing great, but they run into something that they need to go to the warehouse, maybe for some tape or something. And maybe the warehouse is an AI model that you want to ask a question to, like a ChatGPT kind of thing. So this elf takes this long route to get to the warehouse. At the warehouse, the elf gets the thing, and then probably the elf comes back. But of course, the elf might talk to Santa or get a cup of hot chocolate or do something else, and the elf might never come back. And so you have to account for these things in your code, in your automations. Whenever you do a network request, you have to go, what if it fails? And so now you can see network requests are more complex because you have to account. The more network requests you do, the more often you have to put some more logic in your code going, okay, cover for this situation, cover for the hot chocolate situation, cover for the conversation with Santa situation. I hope that was helpful. Hope that gave you some ideas how to interact with code like a programmer. I can tell you in my experience, learning these things transformed the way that I coded, and it also started earning me some respect with senior developers as I made this journey. Of course, this journey takes a little bit of time, so don't beat yourself up too much if you make mistakes along the way, but enjoy it and watch out for those dragons.